Today we're here in one of the longest running annual resolution forest monitoring plots on Earth. I helped establish this plot about 30 years ago as a technician. At the time, we had no idea the kind of information we would get out of this that is related to climate change. We set up this plot where we just follow the fate of every single tree every single year as a way of better understanding what makes a forest work. We go up to each tree in these plots and we give it a physical, where we check to see if it's had insects attack it, or whether some of its needles are dying, or if it has a fungus coming out of it. And if it turns out the tree has died since last year, we give it an autopsy. And the autopsy is we actually peel bark off and do things like that to try to figure out what exactly killed the tree. So we noticed that the death rates of the trees had about doubled over the last couple of decades. But at the same time, there was no change in the birth rates of trees. So what that means is very slowly through time, the forest is getting thinner. Almost all of the rain and snow comes in winter here. Winter is when these forests build up their bank of water, and the bank is in the snowpack. And so when the summer comes, that snowpack starts to melt, and if it gets too warm, that snowpack will melt earlier than it used to in the past. The problem with warming temperatures in giant sequoias is first going to come out, we're going to see it with the giant sequoia seedlings, because as the temperature warms and the snow melts earlier, the poor little giant sequoia seedlings are going to be facing a longer and longer summer drought. If we hadn't been doing this monitoring, we never would have known that. You can't, if you look at the forest behind me here, you can't just look at it and say, it's changing. It's changing because of climate change. That's not obvious just looking at the forest. We had to do that 30 years of monitoring to figure that out.